Hello, everybody, and thank you for joining this session, this talk about architecting Blazor applications. I'm really excited to be a part of this conference. I was there last year in Minsk, and it was really a blast. I really did enjoy it very, very much. So I'm very happy that this year in this very particular circumstances, we are able to gather here, even if in an online version, and just to have some talks about .NET and get engaged, get to talk about technology. I guess that this is really, really good. So I know this is the second day. I know that this is the last talk, but please hold up for just a few more minutes so that we could talk a little bit about how do we want to architect Blazor applications. And what I want to propose is maybe follow some or having some inspiration from other front-end frameworks like Angular, with which I worked, I would say, a fair amount of time. And I guess that when it comes to Blazor, there are some things that we can borrow. But before we go further, just a few words about myself. My name is Dan, and I am right now a business development manager at a company called Avelgo in Romania. But I am also a software developer for quite some years now, and I'm also still doing some development on the R&D projects that we run inside this company. I'm also the founder of a very, very small company called Code Wrinkles, through which I want to help people that don't have any programming experience to get started with programming. And I'm also the co-organizer of a .NET conference in Romania, which is called Apex Vox. It's held normally in Cluj-Napoca, but this year, unfortunately, we won't be able to have a new edition of the conference. So if you want to get in touch with me, but that should be quite easy. But if you search for my name, you would find my blog, on which unfortunately I didn't get the time to write a lot of new stuff lately. But I'm also using Twitter, so there are a bunch of places where you can get in touch with me. But let's not waste any time and just go briefly through what I want to discuss today. So we'll do a very short Blazor overview. I can promise you it will be very, very short, because there were some other sessions where some speakers talked about Blazor, and they did a very good introduction to it. So then we'll go into some, for my understanding, some very important topic, like what should be the folder structure of a Blazor application, and we'll look into that. We'll talk about how to design Blazor components, because this is also something that might come in handy if you really want to develop a real application with Blazor. And we'll also look into some very, very interesting aspects of component communication. So how do we communicate information or state or data between different components? And in doing this, I also have an application which is kind of like a social network. You will see it. So during the demos, we'll see the application working. So what features do we have there? And then we'll do some demo for each of these topics to see exactly how did we implement these concepts in the specific application. And last but not least, a very important topic from my point of view is this concept of micro frontends, and how can we actually implement it using Blazor, because it's really not very complicated, and it's definitely worthwhile to take a look at this whole idea of micro frontends. So let's get started with the short Blazor overview. Talking about Blazor, it's actually, you probably already know it's a framework that helps us to build single page applications using .NET. So theoretically, you can just create a total new application without even writing one single line of JavaScript. And you can still build very rich and interactive UIs, just like you do with JavaScript frameworks. But there is a very, very big advantage that you can really use .NET. So this means that you can share server-side and client-side app logic, classes, and whatever you need throughout your entire project, so backend and frontend, which is actually quite a very, very nice thing to have, I guess. Now, when it comes to Blazor and how do we actually run Blazor, or how do we actually run Blazor applications, there are two different hosting models, and there is that the Blazor WebAssembly, or I would call this the Blazor that runs in the browser like a 100% single page application, SPA. And I won't dive deeper into this topic because yesterday Michael Steib had a session about real-time communication using Blazor and GraphQL, and he did a very, very good intro and showed exactly how the Blazor WebAssembly hosting model works. The main idea is that you ship actually everything to the browser, all your DLL files, and everything actually runs there. Of course, using WebAssembly. And then there is this Blazor server or the server-side hosting model, where actually everything or the entire rendering process and everything that Blazor actually does happens on the server, and there is a SignalR connection, so a WebSockets connection between the browser and the server. And all the new things that should be rendered actually on the browser are sent via this WebSockets connection. So it's quite easy. Now the idea is that the hosting model itself doesn't really play any major role in the way that you actually think about your Blazor application and the way that you want to really design it or architect it. So this is why the content that I present today is not specific for one of the hosting models, but it's really specific for both of them. Actually, the application that I will showcase is it's a Blazor server application, so it has that WebSockets connection, but it could be also a normal or regular Blazor WebAssembly application without any problem. So all the ideas that I will share here are basically or belong to this whole concept of the Blazor programming model. So it's not dependent on the hosting that we have. So let's get right now then into these three very important topics about architecting a Blazor application. And the first thing that I would like to discuss is this idea of folder structure. Because when you start out a new application, this is actually the first thing that you would have to think about. Where do I place all my files, my classes, and so on. And when it comes to organizing an application from this folder structure perspective, there are commonly two approaches that we could follow. So the first one that I would like to talk about briefly is this convention-based approach. Now, as I don't know, .NET web developers developing a lot in this model view controller architectural pattern, we are very familiar actually with this convention-based folder structure. And the idea here is that we create actually folders that follow a very specific and certain naming convention. Like for instance, we have a folder that is called controllers, and in that folder we put all our controllers. We then have a folder that is called services. So in that folder, we can then place all the services that we actually need for that specific application. Of course, this is a very, very simplistic view, but I guess that you get the idea behind. So there are conventions in naming the folders, and we know different parts of the logic of the application we can find in different folders. Now, one problem that might occur with such an approach is that when it comes, for instance, to, I don't know, maybe somebody says, hey, you have a bug in your application, for instance, I don't know, when you try to submit a certain form. Now, the problem is that it's actually, okay, it might be that it's very easy to find where the problem is, but in most cases, it's actually very complicated, because you would usually go from the controller and then search through each different part that controller interacts with, like services, I don't know, domain logic, and so on. So you don't have a very specific place in the application where you know that you could just look there and the problem that you got is somewhere in that specific folder. So you basically have to search actually throughout your entire application. Now, on the other side, at least in the Angular world, there is another option or best practice for organizing folders, and it is that feature-based approach. Now, when we follow this feature-based approach, what happens is that actually each feature is organized in its own folder, and everything or all classes that we actually need for that specific feature only are placed in that specific folder. Now, this or as a result of this, basically all of our features are self-contained. And of course, this makes it easier for us to find problems when they are reported, because when somebody says there is a problem when I try to submit this exact form, then you know to which feature that form actually belongs, and you know that somewhere in that folder that is called features, there should be your problem. So it's actually a little bit easier to find the code that you actually need. Now, of course, then the question comes, okay, and what's the correct way? And as I always say, as it is in programming, the answer is never or almost never just simply right or wrong. And it certainly depends on a lot of different aspects. My idea is that when it comes, for instance, to the backend part, you could, of course, go for this convention-based approach, because that is something that is very, very familiar to you. And at least in my opinion, when you build rich UIs, your UI will get, as also, well, the name says rich UIs, it will get far, far richer than a regular backend. And if you work with Angular applications or React application, I'm sure that you would probably agree with me. So if we want to build rich UIs or rich UI applications, then I would maybe suggest to use the feature-based approach. And by the way, the feature-based approach is also recommended by the Angular style guide. So as Blazor is a regular SPA framework, I would also think that it might be safe or good, or at least a good idea, to also use this approach when it comes to Blazor. However, no matter what type of approach we use, it's really, really important to keep the flattest possible folder structure. And beyond this idea of feature-based folder, when structuring such an application and also following the I don't know, best practices and patterns that we have in the Angular style guide, there are also two very, very specific and very, very important folders at the same time. And it is the core folder, and in this core folder should contain the services that are actually shared throughout the entire application or throughout most of the application. And some examples could be a logging service, an error handling service, the data service, an app state service, and so on. So these type of services you would normally or regularly put in this core folder. Now, on the other hand, there is a shared folder, and this shared folder should contain reusable components that you want to reuse throughout the application. But here, for instance, you should imagine this as, for example, you have a certain type of button that you might reuse in some parts of the application. So so no matter in what part of the application you want to put a specific button, you know that you find it in the shared folder. So each time you have such components, you can just simply put them in the shared folder. And as a very basic analogy to this, you can or when thinking about the house, you can imagine the core folder as the plumbing of the house, or the electricity lines that go actually throughout your house and do lighten up or bring water to all your spaces. And the shared folder, you could consider it as furniture. So you can place a chair, for instance, you can move it from one room to the other, and so on. So as said, this is also something that is suggested by the Angular style guide, and I also think that it might be a worthwhile idea to also implement this in our Blazor applications. So right now, let's go to a short demo about this. But before before I'm showing you exactly how did we structure our application, I just want to show you the application first. And it's a very, very basic social network application that is actually designed or has as a background idea that it should be used in universities, but it's a very basic app. And right now, when we log in, actually, well, we see here a news feed, and these words are actually very, very important, and we'll see why. So we see here a news feed where I can see different posts with the different comments and so on. I can post myself from the news feed or comment on some other posts. But then, for instance, I also have a timeline. So if I click on the timeline, I go to the timeline. And the timeline has different features. Here in the timeline, I can still write posts. I can see some about info about me. I can see all my friends, and I'm glad to have these two ladies here as my friends. Hopefully, I won't get on Sansan's list. But then also the colleagues that I have and things like that. But everything here actually belongs to my timeline. So that's why, once again, this word is actually very, very important. And some other feature that I have is, for instance, if I click on my name, I have this edit profile feature. And here, of course, I'm able to edit some of my basic information, or I am able to change my password. So this is right now what this application basically does. Or now let's take a look at how did we actually structure our application. And if we look at our folders right now, what can we say is here that we have an edit profile folder. So in this edit profile folder, we have a subfolder called components. And here we have all our different components that are needed for this edit profile feature. But besides these components, we have some enums that we actually use only for this feature. So I have an enum here, and I have also some models, of course, because we have some forms there. So we have the models that are specific only for this feature. We put them here. Then we see that we have a newsfeed folder. So this belongs, or this contains actually all the code that is needed for the newsfeed of our application. And in this case, we just have our different components. We don't have models or services or things like that. Then if we go to the timeline, once again, it's exactly the same thing. So we have the timeline. And in this folder, we would place all the files that we need, or all the classes that we need for these specific features. Right now, we have here only some very basic components, which is okay. And here we have also an enum that is specific for this one. To the components themselves, will come just a little bit later, and we look into how we design our components in Blazor. And then we have this core folder, as said, and in this core folder, we actually have right now only one service, that is an app state service. That's what it actually does right now. It takes some information about the logged in users. It returns, it has some methods that returns the claims of that user and things like that, that we are able to inject actually in all the components, and then get this information wherever we need them. But since this is a service that we will reuse throughout the entire application, or through most part of the application, it's like a plumbing or electricity, we put that in the core folder. And then we have also a shared folder. Now in the shared folder, we have also some files that come from the Blazor template that we haven't deleted. But here, this create post component. This is a component that is actually that form that simply makes us, or makes it possible to post something. And if you remember from what I've showed you, you can create a new post either from the newsfeed or from your timeline. So this is why this create post component is actually shared. So we placed it in the shared folder. And then we have some models specific for all the components that we place here in this shared folder. So that's about the folder structure and how did we organize our social network application. So let's go right now to the next topic, and this one is, it gets a little bit more technical, I guess, because it's about how do we actually want to design Blazor components. And that's actually a very, very important and topic from my point of view. And before we get deeper into this, we have to discuss this idea, okay, what type of components do we actually have in Blazor, or how can we actually write our components in Blazor. And the first type of component that we have here is what I would call inline components. Now, the idea of inline components, as you see here in this screenshot, is that you have one single file, for instance, this hello world.razor, and in this file, you actually have the entire markup, but in the same file, with this codes directive, or in this code directive, you also have the .NET code. And this is, well, a very important or a very easy way to design your component, especially if you want to do demos or things like that. And if you watched Michael's session yesterday, you see that that he basically did that. So he had in the same file the entire markup, and he had also the code behind, let's say, or the .NET part, the C# part. Now, as said, this comes in very, very handy. But the problem with this is that when you work on a real application, and if you worked on the front end of different applications, you know that actually a lot of times, even for what it seems to be something very, very simple, you get a lot of markup. So if you have, I don't know, 1,000 lines of markup, and then after those 1,000 lines of markup, then you want to add another 1,000 lines of .NET code, well, from my point of view, this is well, not readable, not easy to maintain, and we should actually look away from that. And this is where actually this second type of components come in, which is what I call the code behind component types. Now, the whole idea in this code behind component types is that we split the markup and the logic into two different files. For me, this is something like, I don't know, the principle of separation of concerns when it comes, let's say, on how do we structure our files. Because actually, if we think about this, there are two different responsibilities here. The first responsibility is just to render the markup. So everything that is related to this responsibility should be placed in one place. But then there is another responsibility, which is to implement the entire logic behind that. So from my point of view, this should then go in a different file. And fortunately, this is actually very, very easy to achieve in Blazor, because Blazor supports by default or has a full support by default for partial classes. And this is why we can simply design our component and have a markup file and then have a separate file, which is a regular C# file where we place all our code behind. Now, as said, from my point of view, my advice would be, or the experience that we had by when working actually on this application, and by the way, what you see here, or what you saw earlier when I showed actually what's possible in that application, this is only a demo version. We have an R&D project that we hope will become a real project that has, well, that will have, of course, a lot more features than that. And I can say that splitting this entire markup and the code behind or logic into different files really does help us very much. Okay, so let's just look here then a little bit in what I actually mean for that. And here, let's go to the newsfeed component, and let's go here to this newsfeed component, which is actually the parent component. And we can see here that we actually we have actually here two different files. So we have this newsfeed component.razor file, and we have this newsfeed component.razor.cs file. And if we look here in this newsfeed component.razor file, we have only markup. And of course, we use other child components and other important things that we need for the entire newsfeed, but we don't have any code here. We don't have any real C# code, of course, except for these loops and things like that. But if we go to this newsfeed component.razor.cs file, we see that this contains actually only C# code. And the only thing that you need to do is actually, when you create a new file here, is just to name it like the Razor file, but also add this CS at the end. And then if you mark it as a partial class, you will see that Blazor or even Visual Studio will automatically link these two files together. So they will work as though if they are one single file, but you actually separate two different tasks into two different files. And it's easier to have an overview about what's happening. And as you can see, there is a lot of code here. But imagine if we put all this code and if we have also a very rich markup in the same file, that could get very, very messy and very, very fast, of course. Okay, so let's go one step further. And then the next very important topic is, okay, how do we actually communicate between components? Now, the idea of communication between components is actually very, very important. And there are, in my opinion, two different scenarios that we can think of. The first one is, how do we communicate between components that are in a certain hierarchy? So like a parent component and a child component, and maybe the child component has even another child component and things like that. So in these cases, as said, we have a hierarchy of components, and we need actually a way to pass state, to pass information through, let's say, from the parent to all the childs, but also from the child to all the, or from the child to the parent. Now, here, this is one scenario. The other one is, of course, when we want to communicate information between components that are not part of the same hierarchy. And in that case, things are a little bit more complicated, because in that case we would have to create something like a state engine or state management engine in our Blazor application that is able to handle all these type of state changes, and components should subscribe at different other components and things like that. But this is not something that I would like to talk about today. Instead, I want to focus on how do we actually communicate between components that are in a, I would say, certain hierarchy. And here, actually, it's very, very easy when it comes to this, because in Blazor, similarly to what we have in Angular and where we know this as input property, Blazor actually works with parameters. So these are attributes. So we have actually properties in our classes that we can mark with this parameter attribute, as you can see in this screenshot here. And this means that in the parent components, when we want to use this component, like repo branches, this is, by the way, from a different application that I worked on, you can then simply say or specify or use the name of that property, and then actually pass in what you actually need to give or to transmit as an information to the child. And in this specific case, we actually have here a list of branches. So this is what we define here. And the parent component, when it uses this repo issue component, repo branches component, it simply provides a list of branches. So by the time this component gets initialized, it means that it also has a list of all the branches, because the parent actually passed this list to the child. And this is how this communication works from a parent to a child. As you see, it's not really very, very complicated. Now, of course, we need also some ways to communicate the other way around. So from the child to the parent. And in this case, well, things could get could be a little bit more difficult to understand. But also in Blazor, we have something that is very similar, by all means very similar, with what we know in Angular as output parameters. The only thing is that in Blazor, we actually call them event callbacks. And Blazor just provides us this option to create or to use an event callback or a generic event callback to provide back, actually a callback to which a parent can subscribe. So when something happens, then simply the child says, okay, something happened, or invokes this callback, and then the parent can actually react to that specific change. Now, of course, since this event callback is a generic is a generic class, we can actually also provide or give an information about, okay, what would happen, or this is what type of event callback is that. And you can see that, okay, it is an event callback of string, which means that the child will actually send this event will generate or will notify in some way the parent about a string or things like that. And then if we know this type of communication, so from the parent to the child and from the child to the parent using event callbacks, there is another very important topic that is actually taken from the Angular style guide, where it is called the container presentation pattern. Now, in the React world, I know that this is, I don't know, maybe known better as smart components and dumb components and things like that. But the main idea is that when we have this type of hierarchy, we have the parent component, which is considered also the container, and the responsibility for that parent component or the container component is to handle any type of data changes. So data retrieval, or if data needs to be modified, only the container is responsible to do that. The presentation components are only responsible for rendering something in the UI. And the idea is that if something happens in the presentation component that should in a way trigger some changes in the state of the entire hierarchy, then it should simply use an event callback and notify the parent, hey, this has happened. And then the parent or the container component is once again responsible to evaluate, okay, this event has happened. So what do I need to do right now? It could be that, okay, I have to, I don't know, to post something to the server or to an API or things like that. But only the container, or in each circumstances, only the container is responsible to handle state changes, not the child components or the so-called presentation components. And I want to briefly show you also this part here. And I guess this is the best way to show that is in our timeline feature. And here in our timeline feature, we have this timeline component, which is actually the parent component. And if we look here in the markup, we see that this timeline feature actually this parent component or container component, we'll see why it is a container component, of course, has a lot or a bunch of different child components that it should render based on different things that happen. But let's maybe take a look about let's take a look about this timeline component and the create post component. But that create post is a shared component. Let's look at something else. Timeline friends component, and here on unfriend. Okay, we have here a certain action that we could do. So let's look briefly into this container component, into the code behind. So you see that this is the container component, and this is why here we even inject the app state service, but also the iService provider. And since this is a Blazor server-side project where, well, you have to be very, very careful on how you resolve your services, what we have in our application, we always resolve the services that we need, in our case, the repositories, where we actually need them. And this means that this component is actually responsible for retrieving data, for, I don't know, handling data changes, and other things like that. But if we go to this timeline where it is timeline, let's go on this timeline cover component, because here on this timeline cover component, we see that what we actually have, let's go in the code behind. Here, since this is a presentation component, we just inject the app state because we want to get information about the claims of the logged in user. This could be also passed in as regular parameters. But what I wanted to show you here is actually that we provide here these event callbacks. And for instance, if we click on a different child, then we have this event callback of active child component. So this is, for instance, when we click on a new link on that timeline, like for instance, about or friends or pending friend requests and things like that. What this would actually do is that it would, for instance, invoke this callback. So for instance, set about active, this method, we set the about link active. So this means that we invoke this callback and say that right now the active child should be the about child. So in the timeline component, then, if we go here, we see that this is the timeline cover, and then we have this active child, you see, and here we provide actually a callback. So actually what happens is that here what we do, we set a different active child. So this time it's very easy actually what happens here, but I guess it's very suggestive. So once again, to understand the entire flow here. So we have this timeline component that is the container component which retrieves all the data that it needs. We have this child component, and when we need to change the active child, we invoke a callback. The parent actually subscribed to this callback, and when this event callback is invoked, the parent does this action. And this is the same thing, for instance, this send friend request. So we have the component that actually provides this event callback for sending a friend request, and the child component just invokes that event callback. This container subscribes to it, and when it happens, well, what it does, it uses the repository and it sends the friend request basically, and this would trigger some changes in the database and so on and so forth. So I guess that that's the main idea of what we have here, and how this communication actually works, and this concept of container and presentation. So I see that I have still 8 minutes. That should be fine, I guess. So the last topic that I want to cover here is this whole idea of micro frontends. Now, micro frontends are, for me, a very, very cool topic, and it's fairly new, I would say. And the idea is that it's actually something that brings, I would say, the whole concepts of microservices to the front-end world. And as you can see in these screenshots here, the main problems that we would have with microservices applications is that, okay, we split everything or the entire backend in tens or hundreds of different microservices, but at the end we still have one front end, and that's kind of like a bottleneck for this. So instead of having this, what if we could maybe split the entire front end into different micro front ends that could be even developed by different teams and owned by independent teams, and they would actually just be put together on a front end without necessarily caring exactly what that specific front end or that specific component actually does. And the whole idea is, as you can see here in the screenshot, we have here, for instance, this front end part or this micro front end 1 that communicates with the microservice 1, the micro front end 2 that communicates with the microservice 2, the micro front end 3 that communicates with the microservice 3, and so on. So the whole thing is, how can we actually bring this to Blazor? And the answer is that this is actually very, very easy to do. And we can achieve this using Razor Component Class Libraries, or RCLs. Now, RCLs are very, very cool because, first of all, they can also or can even include static assets. So, well, you can just add the static assets that you need in that micro frontend or in that RCL, and when you import it maybe as a NuGet package in, I would say, the main frontend, then all the static files will be copied over. So but other than that, in the RCLs, you can then include your own business logic, data retrieval logic, and anything else actually what you need. All services can be stitched together, of course, via extension methods in the program file or program.cs files. And of course, here we can optionally provide even a configuration object that can be used to pass in information like keys, endpoints, tokens, and so on. And eventually, we can create actually a Blazor application that is built entirely from such RCLs, what we could think of about micro frontends in that case. So let's have a short look into how this could look like. So what we have here actually is actually, this is the application. Let's look into this one first. So this is a Razor class library. And the whole idea is that, well, what this Razor class library does, there is a Star Wars API somewhere that you can actually use very, very easily. So what we wanted to do is, okay, let's create such a library that provides you, I don't know, if you want to randomly display in your application some information about a Star Wars character. So we have a component, the character component, that, well, contains all the information about the Star Wars character. And we have also the code behind part. It's very, very simple. We just have 5 characters here, and we just randomly generate one. But the idea is that this is actually a real Razor class library. We have here a data service that is responsible for retrieving the data that it needs. It does this by using an HTTP client. And for this one, we actually use HTTP client factory because we can use it also in Blazor applications. Well, we have interfaces for all the services that we need. We have models and things like that. And we have, of course, also some static files. And everything, this is a regular Razor class library, so we actually cannot run this. But what we could do, or what I did, is I created a NuGet package of that. I didn't push that to NuGet.org. It's just a local package, so I reused it from my local computer. But then I have this other application, and if we go here in the NuGet packages, you see that what I have done, I have installed that NuGet package that resulted from building that Razor class library. So the idea is that, okay, few steps that I had to do is to stitch everything together. In the program.cs class, you see here that I builder services add Star Wars. And this is actually the method, where is it here? This is this one. And what we do here, well, we create a new HTTP client, and then we add this Star Wars data service. So everything happens actually, or the front end, the application that uses this, doesn't even know, or it shouldn't care what happens behind. It should also know that it should add the add Star Wars service, and then everything should be stitched up together. And the other thing that I had to do is in the imports here to just import this characters folder, so that it knows that it should know where to find the components. And here in the index file, not here in this one, sorry, this is in www root, but pages index. What I have done, this is the regular Blazor template. This is a Blazor WebAssembly template, by the way. I just say here, I want to place here this character component that I have actually from that NuGet package. So if I run this application right now, hopefully it works. It worked earlier. Yeah, I think it should work. Of course, now it downloads all the DLLs because it's a Blazor WebAssembly and things like that. And then you see here, I see this component. Once again, if I refresh, well, there are only 5 characters. So with the randomness, in this case, it seems it doesn't work out very, very well. But at least we got Luke finally. So that's okay. But once again, this application, this application doesn't know anything about what it actually needs or what happens. It simply knows that, okay, I have installed a NuGet package. That NuGet package has this character component. I just use it, and that's actually it. And actually, using the same way, you could do this, or you could simply have such Razor class library for each microservice that you have in the backend. And that Razor class library should know then how to communicate to the microservice, what to expect, how to handle data, and things like that. And then you have here this front end in which you actually only stitch together your different front ends. Yeah, and that's actually how we could implement, or this is a very, very simple try on how we could implement this idea of micro front ends using Blazor. So yeah, I guess that's it for me right now. I just want to thank you very, very much for standing by so late. I hope you had some valuable information here, and of course, I'm open for questions.
Thank you, Dan. Thank you very much. It was very interesting. And I don't see no question yet on Q&A list. Folks, please be more active and asking your question. And one question from my side. The idea of Micro-UI reminds me the Composite UI. What is the main difference between them?
To be honest, I don't really have a very, very rich experience working with this. It's something that we used in a certain project that used Angular elements, and this is the first time that I was actually exposed to this idea of micro frontends. I'm really not sure exactly what are the major differences between them, but one is that probably in this case that each micro frontend is really self-contained or totally self-contained.
Okay. So if we have no more question, as Dan mentioned, you could reach him and speakers room and ask your questions. And also just want to remind that in 5 minutes we are starting. Oh, we have one question. How to test front-end part written by Blazor app? Thank you, Igor, for the question.
How to test the front-end part written by the Blazor app. So I'm not sure, does this, I mean, you could write regular tests for the code behind parts for all the components. Could you maybe be a little bit more specific for this testing part? Because actually, when you unit test or when you want to test components, it's actually the same way as you would test regular classes, because you have different methods there, and you can simply create a unit test for those methods. This is why it's useful to work with interfaces, even if you use the full Blazor WebAssembly part, because you could simply just mock the interfaces or mock what actually happens if you want to do that. But it's like testing regular C# code. It's not really different.
I hope, Igor, you got the answer. If no, please clarify your question on the chat. Okay, so thank you very much, everybody, to be with us all the day. And please join the closing ceremony on the first track in 3 minutes. And after the closing ceremony, we also will have after party. Please also join it. And hope then to see you next year offline in Minsk.
Yeah, I hope also. I really did enjoy it very, very much.
Igor provide his question.
Yeah. To my knowledge, there are no specific frameworks for Blazor for now. But for instance, when I wrote unit tests for the Blazor part or for the components, I just used the NUnit.
NUnit. Okay.
Yeah.
So you have, or you use all the framework for the backend and the for front end. Yeah, it's a main benefit, I think, for the Blazor. Okay, thank you, Dan.
Yeah, you're welcome.
Bye-bye.
Bye.
Bye, everybody.